Can I say again? If x is small, say 0.001, then is it obvious to all of us that actually you take x cubed 0.001 to the power of 3, you get a very, very small number. X to the power of 5, even smaller. Follow what I'm saying? Similarly for cosine, if x is 0.001, these terms, x to the power of 4 is very, very small. That you can actually neglect, you can actually not count them, discount them. So the idea in the next chapter is, next part of the chapter is, if x is small, we can, and such that with the x cubed and above, we can ignore. We can have this very good approximation that says, I cannot scroll. This computer are really driving me nuts. We can actually say that sine x is x. You look at your own notes. Sine x is x. Cosine x is approximately, that means you ignore the power 3 and above. Cosine x is this. Tangent x can be shown is approximately equals to x. Don't believe, we try. We try. We try sine 0.0057. You realize that it's very near to sine x is approximately equals to x, because 0.0057 you get 0.00569999. You all follow what I'm saying? It's damn close. Correct? Yes? If x is not small, let's say for example sine 1.54, you do not get anything close to x. You get something that is not quite far away from x. Follow what I'm saying? Important thing, x must be in radians, otherwise it doesn't work. X must be in radians. So, look here, sine x, cosine x is a little bit different, 1 minus half x squared. Tangent x is just x. So we remember this. I think we don't really have to remember the first two. We don't really have to remember the first two because the first two are in the formula list. This one is not. Can I write down? Can you write down first? Can you write down, please? The third one is not in formula list, you must remember. Okay, tangent x is not in formula list. Okay, next slide is also very important. Does it make sense to all of us that if x is small, 2x is also small? That means this, I take 2 times of this, okay, 0.104. You try? Sine 0.0104. You will still get something close to 0.104. Follow what I'm saying? But you don't take 10 times, you don't take 20 times, 200 times of it, then you got a problem. 2 times of it is still small. Yes? 0.5 is not small to begin with. 0.5 is not small to begin with. There's a question here, what if it's 2 times 0.5? 0.5 is not small to begin with. Yeah. I know what you're saying. Where does it, 2 times is an approximation, I remember. There's no hard and fast rule how small is small. In exam, for exam purposes, very often they will just tell you if x is small enough for x powers of x cubed and above to be ignored. Then you just follow instruction. Okay? Yes? The point is, if x is small, you can quite safely say that 2x is small. However, some of us may be very tempted. Let's say I tell you, oh, okay, I want to know sine x plus 1. Then you say, oh, because x is small, therefore it is, this one is just x plus 1. But that's not true, because this approximation is true only when you have sine something and that something is small. If x is small, x plus 1 is not small. I show you an example. This is x. Sine x is approximately x. X is small. What if it is sine 1.005? 5, 7. You get something that is not close to it. This is not small enough for this approximation to be good. Follow? All okay? So x is small doesn't mean that 1 plus x is small. So you cannot use the approximation. Can you please make sure that you don't commit this mistake? Can? All right. Example 20. See, question is always like that. They will definitely tell you that, oh, okay, x cubed and above to be ignored, neglected. Okay? And they give you this thing. You are supposed to prove this thing. Show from here, you're going to show this. It's actually a very simple question. It's quite obvious. From here to here, and really tell you that x cubed can be ignored. Since x is small, sine x is just x. Cosine x is 1 minus x squared over 2. But now you don't have sine x and cosine x, you have cosine 4x and sine 4x. But as I said earlier, if x is small, 2x is small, 4x is also small. So 1 minus cosine x is just 1 minus 4x squared over 2. Minus 4x, because sine 4x is just 4x, equals to 24x. From this point onwards, it's just simplification. I do not intend to go through. You can already get a quadratic equation x. But I want to say that quadratic equation, you have shown it. Hence, find the approximate value for x. Give you answers to 3 significant figures. You got 2 solutions here. You got negative 5 and 0.02. Which one is the correct one? 0.02, because for that thing to be valid, x must be small. Follow? So therefore, x must be small. 0.02. This answer is just 0.0249 3SF. This next part is essentially just saying that if I use GC to exactly sketch this graph and this graph, that means solve cosine 4x minus 4 sine 4x, this GC will tell you this answer. My approximation will give you the answer. Actually, it's very, 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 very close. That's all I want to say. Example 21. Okay, read the question. You actually want to show that QR is this. QR is here. All right. Now, what I'm going to make use of is this idea, cosine theta is just adjacent over hypotenuse, correct? Adjacent over hypotenuse. Now, OP is just, sorry. OP is just A. OR is just A plus QR. Correct? Yes? Now, so first I write cosine theta is this. Now, and then theta is small. So if cosine theta is this, cosine theta is approximately this. So far so good. Yes, because theta is small. Then therefore, this is cosine theta is 1 minus theta squared over 2 equals to OP over R. My objective is what? My objective is to make QR the subject of the formula. Okay? Now, OP is just A because it's the radius. Yes? OR is just the radius plus the distance QR. So the radius plus the distance QR. Can I make QR the subject of the formula I get here? Correct? Yes? I bring this across. Now, the interesting thing is, ultimately, we do want to prove that QR is this. Even if I minus both sides by A, I will get nowhere near to this guy. Follow? Nowhere near, because my theta square is the denominator. Can I just take a lift and then bring the theta square up? Cannot, huh? Doesn't make sense, right? So theta square is the denominator. It's very irritating. Even with my minus A on both sides. Then the question here is this. Is there anything we have learned to make the theta square take a lift and go upstairs? You know what I'm saying? The theta square is the denominator, you know. The take a lift is just rubbish, you can ignore. No. Okay? Theta square is the denominator. You want theta square in the numerator. Is there anything we've learned? Maths? Yes, of course. Okay. Now, I rewrite this like that and see whether it rings a bell, okay? It gives you some clue, okay? Hey, this thing is really driving me nuts. Shut down. Oh, I only have 7 minutes. Shut down, it'll be gone. Die. Oh. Don't worry, it always happens and you will recover. I don't know why. It's really buggy. Come on. I tell you first. This is base to the power of minus 1. Yes? To the power of minus 1. Okay? Hey, okay already. To the power of minus 1. So I write this is equal to A 1 minus theta square over 2 to the power of minus 1. Have we learned anything before that can help us express this as a polynomial? Yes? Where? Here. Yes? Yes or no? Okay, good. Then let's do it. Here. Just leave the A outside. Leave the A alone. Here. Can? And the question already say that theta cube can be ignored. So I'm going to write this next. 1 plus nx. Correct? Do I need to write x squared? Why no need? Because the x squared term is this one, you know. Don't copy. This is your x squared term, right? Correct? This is your x squared term, right? Which actually, if you multiply out, it's theta to the power of 4. Which I don't need. The question already said can ignore. So I can, don't write, I write a, yes, of course you must. You can stop here. All okay? I think the answer is out. This will just be equals to A 1 plus theta square over 2 plus dot dot dot. And you want to know QR, right? You minus A on both sides. This A cancels. Your QR is approximately equals to theta square over 2. Correct? This is this. You minus A on both sides here, and then you get this. Quite brilliant, right? This idea. Yes. And ladies and gentlemen, we have come to the end of my lecture. Please note again, your mini exam, up to tutorial 10.1 only. 10.1 only. 10.1 only, Okay? Math rep, can you collect your new book? It's already ready by Wednesday. Okay? They'll tell you the math rep. Okay? Yeah. See you soon. I don't know when. I don't know when. Should be, should. I hope maybe this year, end of the year, I don't know. Don't inspire me out. Who is the next one? It doesn't matter lah. It doesn't matter lah. Why? Who is your favorite? Mr. Teo No, Mr. Teo won't be coming in. Me? Cannot. I better stop my recording.